Aloha and welcome to this screencast in which I'm going to do a walkthrough of the code for the PMJ-dacruzer build system. Or actually I should say the ICS software engineering build framework as adapted to use in the PMJ-dacruzer robocode system. Okay, so the Ant code for the most part is intended to be a general purpose set of files that you can adapt to any project that you use for Java programming in this course, with a little bit of modification that I'm going to point out to you. But you've read a little bit about Ant, but you probably haven't had a chance to kind of dive in, and as you'll see from the assignment, we have a set of Ant katas to help you come up to speed with your own Ant programming. But I think it'll be helpful for me to kind of walk through some Ant code for you, because there's a few little subtleties of developing build systems with Ant that you might want to be aware of. So let's start off and just look and see what happens when I type Ant in the build system, okay, in our course build system. And what you can see is that there are actually 4 targets that are invoked. There's a download IV if necessary target that's invoked, and you can see in this case there's no output, and that basically generally, well, not always, but it can indicate that actually the target didn't do anything. There's an install IV target which is invoked, and in this case again it didn't end up doing anything because IV has been downloaded and IV has been installed in my particular workspace. And then we have this install libraries, which has some kind of property level configuration information printed out as a result of it. And then there's the compile target, and that also does nothing because we didn't actually, I've already previously compiled the system and I haven't changed any source files since then. So if I did something like ant clean, which deletes the build directory, and now I typed ant again. Okay, what you can, just to go through this, I typed ant and I passed it a target called clean. Okay, so this, you might be asking yourself, look, I typed ant, okay, and it resulted in compile. Now I'm typing ant clean and it results in the invocation of a target called clean. How the heck did ant know when I just typed ant that the compile target was going to be invoked? And we'll see that in a second, but these are some questions that you should be having for yourself. In fact, it turns out that there's this notion of a default target when you invoke ant. There's also the notion of a default build file which is invoked when you invoke ant. So in this case, when I just type ant, I'm implicitly specifying that I want to use the default build file, which in this case is build.xml, and I also want to use the default target specified for that build file, which is going to turn out to be compile, and we'll see where you specify that in a second. In the second case, when I say ant clean, I'm still wanting to use the default build file, which is build.xml, but now I'm overriding the default target and saying I want to invoke an explicit target. In this case, I want to invoke the clean target. So the clean target gets invoked, and it turns out that the action of that target is to delete the build directory. Then I go back and I invoke ant again, okay, again default build target, which is build.xml, default file, which is build.xml, default target, which is compile. And you can see this time, because I've deleted the build directory, that the compile target actually goes ahead and does some stuff. Okay, it creates a directory called build classes, it copies source files over there, and then it compiles 4 source files and puts their output, the .class files that result, into this directory. And then there's this other kind of housekeeping task, which you'll see in a second. Okay, and then because nothing went wrong, we get this build successful in the time that it took. Okay, so if I want to override the default build file, I can say something like ant -f checkstyle.build.xml. So the -f parameter says what's going to follow this -f is the build file that I want to use instead of build.xml. So if I do that, Now you can see the first line says build file colon, and it's saying, oh, I'm going to use a different build file, not build.xml. And then it goes through a bunch of stuff. In this case, it ends up with running check style, and we find that there's no check style errors, fortunately enough. Okay? So that's the command line of using ant. Pretty easy. You can type ant without any arguments, in which case it uses the default file and the default target, or you can override either the target or the file. Okay, so let's get into it. Here's build.xml. Okay, and all ant files consist of are in XML, and they all consist of a project element. So if we look at build.xml, it consists of a project element. If we look at checkstyle.build.xml, it's a project element. If we look at any of these things, okay, it's all going to have a project element. So that's what they all look like. And then all of them need to have this name attribute, which specifies the name of this particular project. And here is the default attribute, which specifies when we invoke this build file, and we don't supply explicitly a target to invoke, here's the target that's going to be invoked. It's the compile target. Okay? Then after it, we're going to have this namespace mechanism. And it turns out namespace is kind of an advanced topic. I don't want to really go into it with you guys right now, but basically what you have to know for the purpose of what you're doing is that whenever you refer to Ivy stuff within a particular build file, you need this little bit of syntactic sugar at the top of the file as an attribute of the project element. Okay, and you can read about namespaces. They're not anything that complicated, but there's really no point in knowing the details at this point when you're just starting to learn about ant. Then we have a description element, which is a kind of a help text that tells the user what it is this particular file is supposed to do. And then we have a task called import, and that's a modularity mechanism which allows you to split up your build code into multiple files and then, you know, import them into the places where you need them to. You need those definitions to be available. So I've created a file called common.build.xml, which is at the same level as build.xml in the directory structure, so I don't have to, you know, I just can specify it as just the file name, not a file path. And the action of this import file is to read in the definitions in common.build.xml as if they were located right there in this build.xml file. Okay, so you know, it has kind of the obvious kind of semantics. So without further ado, let's go look at that common.build.xml file and see what's in there. Okay, so here it is. Okay, as you see, it starts with a project. It has a name. In this case, we're going to call it common. It has this crazy little bit of namespace stuff, which is what Ivy requires. It has a description element, okay? And then it has some property tasks, okay? Properties in ant are very interesting in a few different ways, okay? The first thing to know about properties in ant is they're immutable, okay? And what that means is that when you define a property in ant, you can almost think of it like a variable. Okay, so this property name equals source dir, location equals blah blah blah, base dir blah 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 slash source. It's like you're defining a variable called source.dir and giving it the value of whatever this turns out to be. Okay? But there's one very interesting thing about properties in ant that are different from variables, and that is that once you assign a value to a property in ant, it cannot change its value for the duration of that build. Okay, so they're immutable. Once they're set, they're fixed, they're constant. Okay, so you can't create a source dir and have a loop where you iterate through a bunch of directories and you reassign source.dir as a variable to different values at different times in that loop. Okay, that was a huge design decision, contentious, still debated about whether, you know, it does limit certain capabilities of ant, or it means that certain things that you might want to do in a build process are somewhat more complicated to do because of the fact you don't have mutable variables. Okay, unlike a regular programming language like Java or whatever. On the other hand, it does make certain other things. It makes it easier to reason about the build. Okay, and it creates a more declarative kind of structure to build files. okay, which the originators of Ant were going for. So anyway, that's the way it is, okay? And so when we have a so we're going to define variables, but just keep in mind that once you define it once, it can never change. Okay, so we're going to define it for the, until I invoke build again. Okay, so I'm going to define a variable or a property called source.dir, and it's going to turn out that this property is a file path. So I'm using the attribute location to specify the value of this property. We'll see other places, hopefully. Here's an instance where we say property name equals iv.version, value equals 2.2.0. So it's possible to have in a property you have to have the attribute name, which gives the name, and then you can either have value or you can have location as the attribute which specifies what that property is going to be defined as being. Okay, you use location when you want the value to be a path to the file system, which is very, that's a super common thing in build files, right, is to be specifying file paths. Okay, now one reason why you want to use location, and one reason why you want to use Ant in general, is because of file path handling. Okay, so let's look at this source.dir. The first thing you're going to notice about this is we have this $ left curly brace base dir right curly brace. It turns out that in Ant, when you run a build.xml or any file at all, there are certain properties that are defined implicitly for you, and one of them is called base dir, and base dir is the current location in the file system of this build.xml file. Okay, or the current directory that it resides in. Okay, and when you want to refer to the value of a property inside a string where you're creating some other property or whatever, what you do is you enclose the name of that variable in these metasyntactic characters, the $ left curly brace, $ right curly brace, which says substitute in this space in this string the current value of base dir. Now remember, because properties are immutable, base dir always and only has one value for the entire extent of the build. It can't change. Okay, so it turns out that if I do like a print working directory, okay, so it's going to turn out that base dir has this particular value. Okay, because that's where I am when I invoke Ant. Okay. Now next, I have a / and I have source. So I'm specifying that the source directory for this particular build is located in a subdirectory of the current directory called source. Okay? That's really cool. I mean, that seems fine, seems obvious, seems simple, but there's something super elegant about this. Okay? What's super elegant about this is that this works on Windows. Okay? And you say to yourself, so what? It works on Windows. Well, remember, on Windows, the file path separator is the \, not a /. Okay? And it turns out in Ant that Ant magically protects you from the idiosyncrasies of any particular operating system. And when I say any particular operating system, I'm really talking about Windows, because that's the operating system that has idiosyncrasies. Okay, I guess I stand by that. So what happens is that if you're running this build system on a Windows platform, when you actually try to do a command that involves this source.dir directory, Ant is going to pass to the underlying operating system a path with \. Okay? Which I think is just, it's totally awesome, right? Now we could, on the other hand, put a \. Here. And remember, in Java strings, one \/ is a escape character. So we have to have two \s in a row in order to emulate, in order to indicate a \/ in a string. It turns out that I could substitute this for the / and things will still work great. If you specify it as a \ and you're running on Unix or Macintosh, it'll put a / there for you. Just because I don't like the look of two \, I always use /s by convention, and most people in build files will do it that way because most people like less characters and they like using a forward slash. And you just don't even worry about it because on Windows it will convert it to backslashes for you. So there's one huge great thing about Ant that you get right off the bat. If you're working in an environment where some people have Windows, some people have Unix, you don't have to worry about any of this file path stuff. It's automatically taken care of for you by the build environment. Okay, so we're going to define three properties, source dir, and you can see actually Eclipse in its infinite wisdom is actually showing me what the value of source dir is in this little tooltip that pops up. So it's figured out what base dir is because it understands about Ant, and then it computes what the value of source dir is and shows you what it is. Similarly, there's a lib directory and there's this build directory, and it's all kind of the same thing, base dir plus the appropriate subdirectory. Now, the next thing is a condition element, and I want to talk with you about what condition elements are. And before I do that, I think it's interesting to ask yourself, why is it that, well, let me first say what this thing is. Okay, what we're going to do is we're going to check to see whether or not Java 6 is the current version of Java that's being invoked when we're running this build system. And if Java 6 is not the current version of Java that's being run, then the build will fail immediately and say, you can't do this because this system needs Java 6 and you don't have it installed. Okay? So that's what this little piece of code is going to do. And you might ask yourself, well, Johnson's already said we have to run Java 6, so why is he running this code? The reason is I'm trying to show you a general feature that you should include in all of your build systems, which is to check to make sure that the recipient of your system has his or her environment set up with the appropriate versions and the appropriate tools to actually do things correctly and to fail early with an informative error message rather than fail later with some bizarre message that's very difficult to trace back to the fact that they had Java 5 installed. Okay? So even though everybody in this class obviously will have Java 6 installed because you're all following your directions correctly, we want to build this system as if any random user on the interwebs was downloading our system and just typing Ant and just wanting to see what happens and isn't necessarily looking at the documentation and figuring out that they need to have Java 6. Okay, so that's the goal of this. We're also checking to make sure that we're running Ant 1.8, and this is good hygiene for any build system that you build, is that you do a certain amount of checking to make sure that the tools are appropriate for whatever, satisfy the requirements for whatever your system needs to do. So now let's see how we actually do this check in Ant. What we're going to do is we're going to use a combination of two tasks, the condition task and the fail task. The way the condition task works is that it has these interior elements which are basically predicates which are going to be either true or false. Okay? And if these interior, and you can have multiple ones, this condition only has one interior element, but you can hook them together with ands and ors and do all sorts of kind of Boolean logic on this stuff. And you can read the documentation about condition to see all the different contains and interior elements that you can use. But you can just read this and see, okay, I've got this property called java.version, which turns out to be another property predefined by Ant for you. Actually, if you know the system.properties class in Java, the system class in Java, the properties element, there's a properties method of that class that returns a set of key value pairs. All of those are just implicitly defined for you in Ant as properties that are available to you. And java.version is one of them, and we look to see whether the substring 1.6 is in there, and if so, we assume that we're running some version of Java 1.6. Okay? Now, if that predicate is true, we will define this property. Okay? We're not giving it a value, we're defining it. Okay? And then, in this fail task, we print out this message and fail the build if java.6.available is not defined. Okay? Now this is interesting because in normal programming languages, right, you have a variable and you test to see whether it's true or false. Okay? In Ant, the way you kind of check things in this, with this unless clause, there's also an if clause, is by checking to see whether the variable is defined or not. And that's one of the implications of this immutability of variables. Okay? Is that you, because variables can't take on different values at different times, okay, the more convenient thing to do is to actually just test to see whether or not they exist, and then to have predicates or tasks that actually define properties as a test to see whether some kind of condition is satisfied. Okay, so this is not, unless java.6.available equals true or equals 1.6 or whatever. It's unless we're going to fail the build unless this property is actually defined in the system, and this condition task will define this property if and only if this predicate is true or satisfied. Okay, so that's how it works. This condition was going to end up defining this property java.6.available in the event that this is satisfied, and then this next task that we invoke right afterwards is going to fail the build unless it sees that this property is available. In most cases it gets defined, so the fail won't work. Exactly similar, and you can see here I've embedded this in an AND element just so you could add more things in there if you wanted to make it more precise. We're going to check to see that ANT 1.8 is available, and then we'll fail the build. And here you can see inside my message, which is printed out, I'm actually telling you what version of ANT you have installed. Okay, and I could have done this up here. I could have printed out the value of java.version if we cared. Okay, so these are examples of various kinds of things you can do. So we've checked to make sure we're running java.6. We've checked to make sure we're running ANT 1.8. This is all part of build.xml. I mean, we're in the common.build.xml file right now, but we've imported it into the build.xml. So we're actually going to invoke all this stuff, right, as part of loading the build.xml file. Okay, now we're going to define some stuff to download, if necessary, Ivy from the web and install it. Okay, and so we're going to define this thing ivy.jar.path, which is a property whose location is going to be the user's home directory in this .iv2 subdirectory, which is where Ivy stuff generally gets put. And we'll have a new directory called ivy.jar. We're defining the version of Ivy that we're interested in, and then we've got this predicate called this predicate called this task called available, which defines this property ivy.available if it's the case that we found a file called ivy.jar in the ivy.jar.path/ivy.jar place. Okay? So at the end of this stuff, basically we've defined some new properties, and we've got this ivy.available if we've already got Ivy locally. Now why do we need that? Well, we're going to now want to install Ivy. Okay? And in order to install Ivy, we first have to see, is Ivy available locally, or do we have to download it from the net? So let's make this task, install Ivy, depend upon another task called download Ivy if necessary. So let's go look at that task and invoke that one first, because that's what we would have to do in order to install Ivy. Well, download Ivy if necessary has this unless attribute attached to it, which says this whole target, if we're invoking it, we do not have to do it if Ivy has already been shown to be available by this available task, which has defined this property if it found it. Okay, that makes sense? So if this property is not defined, it means that we were not able to find ivy.jar, which means that now we're going to make the ivy.jar.path directory, and we'll call this get task, where we pass it a URL that we want to download, and we pass it where we want to put it. Okay, and then we have this use timestamp attribute, which says don't download the remote version of the file unless its timestamp is newer than the timestamp on the file that's already locally available. Then we're going to define some more properties. The config files.url is the location of the configuration files. So remember, I spoke previously for our quality assurance tools like check style, PMD, find bugs, etc. We have these configuration files which specifies what kinds of things check style is going to look for in our source files. Things like, what's the acceptable level of indentation, or the number of indentation spaces. So in a configuration file for check style, we would say we want 2 spaces to be the valid amount of indentation, and then it can check for that. So this little bit of code here is to set up a location in our lib directory where we're going to store these configuration files. Okay, and then I have a few other targets like clean. You saw that earlier, which deletes the build. Really clean depends upon clean, which means it's going to not only delete the build directory first, but then it will also delete the lib directory. And then there's this final target that in cases where sometimes you can get this situation that you have a file that's a mixture of Windows line endings and Unix line endings, and that can be bad for certain configuration management systems. So very infrequently you might want to run this target to make sure that everybody has the same kind of line endings. Okay, so what have we done? We've just spent all that time to get to line number 3 of our build.xml file, but it's important to kind of understand the sequence of things. And also, hopefully, it now gives you a sense that when we type ant, where do we type ant? Well, let's just type ant again. If we type ant, okay, we now see that we want to invoke the compile target because that's the default target, but instead we're going to before getting there, we're going to invoke a sequence of other targets before that. And let's just quickly go through that dependency structure. We can see, well, first we can see that the default target is specified up here as compile. So if I just type ant without any arguments, the system's going to know that compile is what I want. So now I can see that in order to do the compile target, the first thing it wants to do is install Ivy. And that's available because we've imported common.build.xml. And install Ivy, which is here, depends upon download Ivy if necessary. So that means we've got to invoke download Ivy if necessary first, and check to make sure that's okay. And then we'll invoke install Ivy. And then we'll invoke, after that one's completed, we have to also now do the dependency install libraries, and then finally we can do compile. Okay? So you should be able to understand that dependency chain, and if I gave you a simple ant file with a bunch of different dependencies listed like this, you'd be able to trace through and at least list the sequence in which things get invoked. That's a kind of an essential ant development skill. So anyway, now you can see after doing the common.build.xml, we define a couple more properties: JUnit version, its value is 4.9, robocode version, current value of robocode. Now we have this target called install libraries, and the idea of install libraries is to make sure that the libraries we need for this particular system are going to be available in the lib directory. So in the case of robocode programming, the libraries that we need are the robocode libraries and the JUnit libraries. Okay? If you're doing, web application development, you might want to be installing the Jetty library or the Tomcat library, or who knows what third-party libraries you need. Okay? But this is kind of the appropriate place because now we have Ivy installed, and so using Ivy we can now go out and get whatever third-party libraries our particular system needs. Okay? Now it turns out that the syntax for using Ivy is frankly somewhat complicated, and although the complications are warranted because one of the nice things about Ivy is it has a rather nice and sophisticated dependency management language which allows you to do a lot of stuff. It's a little complicated to understand at first. So I'm going to now again say that this little piece of code as a beginning Ant programmer is going to be a little bit of black magic for you. Okay? I'll also say that the Maven stuff is even worse. So it's not like dependency management is not inherently complicated. It's inherently complicated. Okay, so but I feel like I should come back to this later rather than delve into the complexities of the Ivy stuff right now. But what we'll see here is we have a bunch of these Ivy retrieve tasks. Okay, and we are going to specify for JUnit that this is the retrieve task that's going to get our JUnit module. Once we've downloaded our JUnit module into the lib directory in a subdirectory called JUnit, and it's going to turn out to be named junit.jar by use of this kind of syntax, then we can invoke a task called path. And this is a very important task which you should understand in Ant. Okay? So we've got project, we've got import, we've got property, we've got condition, we've got fail. What else have we got? We've got path. Those are the ones I'm listing off right now. Those are the ones that you should understand how to use those guys. Okay? Defining targets, target, and then depends. That stuff you should have in your toolkit. Okay? The path task enables you to define a property called, well, it's not actually a property, but define something, a path object, let's just call it that. A path object with a name, in this case junit.path, and then you specify a location for it, just like you would for a property. And you might ask yourself, why not just name a property called junit.path? And the reason why is that a path variable, if you know from your Java days, actually a path variable can have multiple elements on it, separated by semicolons in the case of Windows and colons in the case of Unix. Another place where we have this platform-specific behavior, and to our great delight, as you might now expect, Ant is going to take care of those details of path separator characters, figure out what platform it is, and make a path that has the right separators depending without us having to worry about it. So anyway, we're going to define this path object. In this case, it consists of only one path, but it could, in general, consist of multiple paths. And we're going to assign it to be junit.jar, which this retrieve has created for us. Then these next set of Ivy retrieves are all involved with creating various files and subdirectories in the robocode subdirectory of the lib directory. Okay, and we're going to get, the top level robocode.jar, and then we're going to battle subdirectory, a robot subdirectory with all the samples in it, templates, blah, 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 all this kind of junk in here. And once we've done that, once Ivy has retrieved all those robocode modules of the appropriate version, by the way, then we're going to define a new path called the robocode path. And it's going to turn out that in the robocode path, we're going to have two jar files, one called robocode.jar and one called robocode.testing.jar. And again, those elements of this robocode.path variable are going to have a path separator character appropriate for the platform. Okay? File set turns out to be another Ant target that you should understand the use of. It's so useful because now you can define a set of files and absolute paths in one task. Okay, and that can be very useful in a variety of settings, such as this one. Okay, so that ends this install libraries target, and essentially the goal of this install libraries target is to simply define the JUnit path and define the robocode path and ensure that these paths actually point to files that exist, which is what the Ivy retrieve tasks are doing. Okay? Pretty simple, really. Okay, then the next piece of build.xml is to define a property called system name. In my case, it's going to be robocode-pmj-dacruzer. In your case, you're going to edit this. Okay, when you're using this build system as a template, you're going to edit this property to be the name of your system. Similarly, you're going to edit the name of the major version number to be whatever the major version number for your system is, although it generally should be 1. And the minor version number, probably want that to be 0, you know, or maybe 1. Okay. And then we've got this day stamp thing, which is going to be the month, the year, the month, the day, the hours, the minutes. And as I talked before in the lecture, we append this onto the major and minor version number so that we have a sense for, we have a unique version number for each distribution, which is also going to indicate the time at which it was created. Okay, so now we're going to create yet another path object. This path object is called compile.classPath, and it is a composite of the JUnit path and the robocode path. Okay, so this is really cool. You see what I'm doing? We've got this very modular kind of process here where we download the JUnit file using Ivy. We set a path object to point to the jar file that we downloaded. Do the same for robocode. Create a path object that points to the multiple files in the robocode distribution that we need. And then what do? Well, there's various places that we might need to use these library files. We might need to use them for compilation. We might need to use them for execution, testing. It's a whole bunch of different contexts. So I'm creating a path object called compile.classPath, which says here are the libraries that you need explicitly in the case of compilation, and they consist of these two other path objects, which Ant will magically compose together in the appropriate way for the operating system when we actually invoke things. Okay, now we're getting to the actual compile target, which is what we wanted to do from the beginning. It's amazing how much junk, right, we've had to go through, but really there's a lot of complexity and cross-platform stuff that's being taken care for us in a relatively small number of lines of code. Now I have to admit XML is quite a verbose format for expressing this stuff. There's a lot of people that say that's a big mistake that Ant made using XML. XML is not a good format for this kind of thing. I have to admit I do agree with them. XML is kind of a junk syntax for humans to be reading and writing. But that's what they did, so, you know, oh well. It's the standard, and there are, you know, there's other build files like you know, Rake, which is kind of raw Ruby code augmented with some libraries, and some people prefer that. Okay, and I can understand that. Anyway, we get to our compile target now. It depends upon two other targets. We went through that previously. We have a little description attribute which specifies what it's doing. Let's see what compile actually does. We're going to make a directory called build.dir/classes. If the directory already exists, no problem, we don't fail or anything, we just don't make it. Then we call the javac program on the operating system, and we're going to specify that the source directory is source_dir. Remember, we defined that property before. Now we're getting the value of source_dir. Okay, and you can see Eclipse is now using a tooltip to tell us where that is. We can specify the destination directory, okay, right there. And we can say that we want debugging to be on when we run it, so we get useful information. We don't want the Ant runtime included in compilation, so we don't want stuff that we've loaded into Ant as part of making this build system work to be accessible during compilation of our robocode system. That would not make sense. So we say no. And then we specify the class path to be used for supplemental libraries to be available during the compilation of our particular system. And the way we do that is we use this ref_id attribute and just specify compile.classPath, which we defined up here. Okay? And if you can see, look at this. This is pretty cool. We've got the path elements associated with this that pops up in a tooltip. Okay? There's a couple compiler arguments that basically make the compiler do some additional error checking. You can look them up. There's this lint property, and there's this -w error property. you know, they just make the compiler a little more careful about bailing if it runs into things that it doesn't like. And then this final thing is a copy command, and what we're going to do is we're going to copy to the robocode robots directory all of the dacruzer class files found in this class's directory. Okay? Now, why am I doing this? Well, it turns out, remember in Eclipse, we could specify in Eclipse that we have a, I'm sorry, when we run Eclipse, we could, when we run robocode, we could go into that development options pane and say, oh, by the way, there's this other place you can look for robots, which turns out to be the working directory of, you know, my Eclipse project. So that's one way to make robocode aware of the robots. The other way you can make robocode aware of the robots is to simply copy your robot class files into the robocode robots directory. Okay, and that's what this little piece of it does. Okay, because again, this is an Ant build system, right? We don't know that the user running Ant is also running Eclipse. They could be using Emacs or IDEA or NetBeans or, you know, who knows what. Okay, so this copy command is here under the assumption that someone running this build file will want to copy the robot that was created using this compilation over into the robots directory. So if you invoked robocode from inside the lib directory, you would now get your robot, okay, available to you to battle. Okay, so that turns out to be how the default build.xml file works. And now you know, I would say 75 to 80% of everything you need to know about Ant. Not everything, okay, but the katas will take care of that. But you hopefully will have an idea about how Ant works in general, and you'll be kind of bootstrapped. So by looking at the manual and tracing through code and playing around a little bit, you can see other things. Let's just look at the checkstyle build.xml file, because that works a little differently. Okay, and the best way to understand these things, I think, is always to just try to invoke them first, okay, from the command line, and then see what the heck happens, and then try to trace through, right, the actual code so that you understand the sequence and everything that happened. In this case, what we see is that apparently the target that, well, not apparently, but actually, since I didn't specify a target when I invoked ant-f checkstyle, it turns out that the default target had to be checkstyle because that was the last target that was invoked. And then we had this checkstyle report, checkstyle tool, checkstyle install, blah, blah, blah. So let's try it. And then we also had compile, install libraries, install Ivy, download Ivy if necessary, which we've seen before. Okay, so let's take a quick look there to see how that works. Here's the checkstyle build.xml file, and you can see it's a project element just as always. The name of it is checkstyle. The default target is checkstyle. Okay, check. That makes sense. And then we have this stuff that's there because we're using Ivy. Okay, got a little description element here. Now we have an import of build.xml. Okay, which is interesting because build.xml imports common.build.xml. So in fact, when we invoke checkstyle.build.xml, actually 3 build files are being loaded. We're not only loading checkstyle.build.xml, but we're going to load build.xml, and we're also going to load common.build.xml. Okay. Then we define a whole bunch of properties. I'm not going to go through all these properties because now you should be able to read this yourself and figure it out. You'll notice that some of them use the value attribute, some of them use the location attribute. They use the location attribute when what you're trying to define is an actual path on the file system. And then we get the magic with the, you know, the path separator characters. Okay? We check to see, and this is the available task, we check to see whether or not the checkstyle.config.file path is actually defined. Okay, and here it is, or available. Okay, and if it is available, we have checkstyle.config.available. Okay, and so now we see that install checkstyle. Well, let's see. Okay, I think that the best way to proceed at this point, when we look at targets, is to start by looking and saying, what does checkstyle want, right? Because we're invoking checkstyle. That's the default target. So it turns out if we look at the check style target, what it actually doesn't do a darn thing. Okay? The body of check style is empty. Okay, so the entire effect of the check style target is its depends attribute, which says that this is going to depend upon compilation, then installing check style, then running the check style tool, then running the check style report in that sequence. Okay, so the first thing it wants to do is compile. Okay, and then remember that compile depends upon doing all this Ivy stuff, right? As we saw before when we just invoked ant. So that's why when we invoke check style, the very first thing that happens is we check to see if we need to download Ivy. Then we check to install Ivy if we need to. Then we define our libraries, which is JUnit and robocode. And then we invoke compile. Okay? It turns out since I have invoked compile previously and no source files have changed, the compile target doesn't have to do anything except check to make sure that it doesn't need to do anything. Okay? So that's why the first 4 targets of running this check style target or check style build file are what they are. It's because the check style target was the default target, okay, and the check style default target, the first thing it wanted to do was make sure that the compile target was satisfied. After that, it wants to install check style. Well, install check style depends upon installing Ivy. Okay? Now what's interesting is that install Ivy was already done once as part of the compile target. Okay? Very tricky. Okay? So it turns out that because of the fact that Ant realizes, hey, I already satisfied the install Ivy target as part of satisfying the compile target, so I don't need to do it again because I've already done it once, even though it appears later in the dependency hierarchy. Okay, which is a pretty cool thing. You might ask yourself, well, why is it that it's even listed here when we're already going to do it as part of this compile target? And the answer is, what if I said ant -f checkstyle.build.xml install checkstyle? Okay, what if I called this target directly rather than implicitly through invoking this target? Okay, so this is the other thing about the definition of build files as you think about it, is that when you define a target, what you do is you go ahead and you say, well, if I want to install checkstyle, I know that to install checkstyle, it really Ivy has to be installed in order for me to accomplish that task. Okay, and I'll just put it here, and I don't care where else the install Ivy target might be dependent upon. Doesn't matter to me because I'm going to let ant take care of figuring out where in the sequence of invocations it needs to invoke install Ivy, and it will do it in the right spot. And I can just be sure that at some point prior to the invocation of this install checkstyle target, I know install Ivy will have been called someplace. It's really rocking, right? So now you're starting to, I hope, you're starting to see why build system development and build system programming is kind of a different animal from conventional, imperative programming. Okay? It's got this different flavor to it, which is a cool flavor if you ask me. It's, chocolate versus vanilla. They're both good, quite different from each other. Sometimes you want vanilla, sometimes you want chocolate. It just kind of depends upon the situation. Here's a situation where this whole dependency, structure of development can work out really well for you. Well, what does install chocolate? What does install check style? What does install? I've never done that before. What does install check style actually accomplish? It invokes Ivy retrieve to download or basically put into the lib directory the check style executables. Okay, that's its sole function. And then remember that we associated with check style, we have this configuration file where we specify our class-wide standards that check style is supposed to verify, and that's what this target does, checkstyle.install.config file. It first checks to see whether this property has been defined, right? And this property has been defined if this available task has succeeded in finding this actual file on the file system. Okay, so we don't execute this target unless we this thing has not been defined, and if it hasn't been defined, then we invoke this get method, which goes out onto the web and downloads the file from there. Okay. Similar to the build.xml, similar to the compile.class path, we have a checkstyle.class path, which is going to define the set of path elements for checkstyle to operate correctly, which is going to be all of the classes in our system, plus all of the libraries that we needed for our system. Okay, which is kind of interesting. And then the checkstyle.tool target is the one that actually invokes checkstyle. The checkstyle report target takes the output of the checkstyle tool, which is in XML format, and then generates an index.html file. So what you can actually see is if we go to robocode-pmj-dacruzer and we look in the build directory, here's a checkstyle subdirectory, and here's index.html, which was produced by that checkstyle.report, and we double click, and now we can see you know, in a nice HTML format the problems that occurred or didn't occur when we ran checkstyle. Okay, this is the same for find bugs, the same for PMD. So when you run these systems, if in fact you have a failure, what you do is you go in the build directory and the associated subdirectory for checkstyle, PMD, or find bugs, double click index.html, you get a nice report that tells you how it actually failed. Okay? And that, I think, is all that I need to tell you. I think you're pretty much good to go. You know, you need to know make dir, file set. Okay, these other ones, XSLT, that's kind of a more advanced one. Definitely how to make paths out of path elements and paths. That's, you know, kind of basic everyday Ant usage. But, you know, in general, if you understand the dependencies, if you're able to kind of invoke the XML, the build target, and then trace through. The other thing I want to show you, actually, which will be very helpful, is that you can say ant minus verbose. And if you say ant minus verbose, you get a lot more information about what it is that Ant was doing as it processed things. So as you develop Ant code in your katas, you might want to try this ant minus verbose trick to kind of see whether or not things are happening the way that you'd like to. Okay, that's it for now. Have fun.